When something goes wrong in a book language program, our interpreter raises an error. For example, in this case, we have 1 applied to 1, and so our interpreter raises the not a function error. While we implemented the error call in our interpreter, we didn't actually implement errors as aborting a program and showing the result. And also we're relying on VLAI typed here to catch exceptions through testxen. What I mean by the abort part is when we discover that there's 1 here is not a function, then somehow we manage to jump all the way out and say not a function instead of trying to add an erroneous value to 1. What we want to do now is stop relying on PLAI types implementation of errors and implement it ourselves, so that our test will now be interp of the same expression should produce an error v, not a function. So errors will be a funny kind of value that is easy enough to add, but the interesting part of this is how do we jump out of the whole program when we encounter an error. To implement this, we can start by adding error v to our interpreter. So an error v will just have a message string inside of it. And now we need to look at every place that we use the error function and see if we need to change it. So I'll search for error. That one's in testing. This one is in the parser, and we're not going to worry about the parser since that's outside our interpreter. But this is the not a function error that we're raising. And so this is the place where instead of calling the error function, we're going to just return error v not a function. And here's the place where we raise not a number. So now we want to change that to be error v not a number. And finally, here is the lookup error. Error v free variable. And that's all of our calls to error. And we also need to change all of our test exns that have to do with interpreter errors. So not the parser errors again, but we do want this free variable test should not be an exception at the PLAI level, but an error v from our interpreter. And here are more test exceptions. So the first one should be an error v not a function. Second one is an error v not a number. This one I'm going to set aside for a moment. I'm just commenting it out. This one is again error v not a function. Okay. So with that change, we can run our interpreter, run up all our tests, and we've hit 1 error. That's beat B because I didn't fix up this test. There was 1 more test where we test lookup directly. Now all our tests pass. And we see that if we run interp on parse 1.1 in an empty environment and an empty continuation, then we get the not a function error that we expected. And we get that even if it's nested inside of an addition expression, just like that. We see that if we get a free variable, like x, that it's an error v free variable. And what happens when we nest that inside of an addition expression? This time we got not a number, which is not the error we expected. We expected to get free variable because x is the free variable. So what happened here? Well, to understand, we can look at interp. In the IDC case, this is where lookup returns error v free variable. But instead of returning that as the result immediately, we pass it on to continue. And the continuation of that free variable error attempts to add the free variable value, error value, to 1. And that's error v for free variable is not a number, so we end up with a not a number. This is not the behavior we want. Instead, we want lookup to not call the continuation when it wants to raise an error. Right? And that is the essence of raising an error and aborting the whole program. It's not using the continuation. So instead of calling continue with k, we need to pass the k down into lookup so that lookup can decide whether the continuation should be applied. That means our lookup function now takes a continuation and in the ArrV case we just don't use it, and in this case, which is where we return a successful value, that's where we want to continue with k. So that's the key part of error handling right there. Not using continue k here, using it when we do have a value. Now we just need to fix up all of our tests. And one more test. To test them all with the empty continuation. And let's see, I forgot to pass k along in the recursive call. All our old tests still pass. And now when we put a free variable inside of a plus expression, then we get the expected free variable error. Again, it's because we're not using the continuation here. We only use it in the successful case. And it turns out that that was the reason I skipped over this test here, because it was exactly the same problem. So we do have a test case for this new problem that we just fixed. Let's double check that our uncommented test case works. Alright, let's try a couple of more examples. So that one works right. Suppose we have that used as the function position. Right, so we want to make sure that we got free variable and not a function. Right? And let's see, let's suppose that we try to add 1 to a non-number, a lambda xx. Okay, then we get the not a number error that we expect. And let's try nesting that inside of an application. Right, so the key is we want to get not a number from this, not a function error message that would happen. Oh, and we got not a function. So the same thing is happening here as before. If we look at continue, in the do add k case right here, we attempt to add two values with num plus. If one of those values is not a number, it returns the error v, not a function. But again, we just continue on with next k, no matter whether we get an error or not. The solution is the same as before. We want to take next k and pass it into num plus so that it can make the decision whether to apply the continuation. And num times will be the same. Right. So either num plus or num times are responsible for calling the continuation now with continue. So both of those take a k argument. We need to pass it on to num up. And now num up in the success case can continue with k with the successful value. Otherwise, in the error case, we have not a number. And let's take this example here and make it one more test case. The result that we're expecting here is the not a number error, as opposed to the not a function error. And I need to fix up more test cases. And with those changes, all of our tests pass. So let's double check again. Everywhere we have an error v that we are using, it has to be in a place where we have the continuation and we choose not to use it. So that was true right away in do app k, just because of the way we had written things. We don't use next k there. That's just some tests. Here is a use of error v in num plus and num times, but the k that we're choosing not to use is that k. In lookup, we have the k that we're choosing not to use, and that is all of our error v's. So that means we've got all of the error cases done. Just to recap, what we did was we used error v instead of error, and didn't use next k or k here. In lookup, we added a k to use, and in num up, we added a k. And that's all the changes that we need to take control of error reporting and not rely on PLAI types error reporting.